everybody. Hello, there you are. Welcome to three-dimensional trigonometry, and it's just normal trigonometry with more triangles. And because it's 3D, you've just got to, if you do heaps of these questions and keep working on it, you will develop the knack of being able to look at a diagram that's in 3D and be able to pick out the separate two-dimensional triangles that we can then solve. And so I'm going to be recording my solutions to all of these questions and going through how to create your diagram and which bits of it we actually want. So for the first question, if we have a look at this diagram, they've asked us to use Pythagoras' theorem to find the length of the base diagonal BE. So they want this length here. So if we have a look at this one that I prepared earlier, we're after the length BE, so let me select that line, it's that line there. So we need to kind of make a 2D dot triangle out of this to be able to do that. Now, is it going to make sense to do a 2D triangle that way? No, because I can't see BD. This way? No, I can't see BD. This way? Yeah, I'd say that's the best way to do it. So we're going to draw our two-dimensional triangle. We're going to make sure we label everything, by the way. So we're going to have the point B. We're going to be looking at it from a bird's eye view. F, E, and point A. So what we've got is essentially a rectangle. Oh, come on. And this length is 12, and this length is 9. And we want to know the length of this diagonal here. That's the line BE. So we're going to use Pythagoras, because this is a right angle, and this one is also 9. This one's also 12, frankly. So I know the length BE is the hypotenuse, so BE squared equals 12 squared plus 9 squared. So BE squared equals, calculator time, squared plus 9 squared, 225. So the length BE equals the square root of 225, which is 15. And then so that was A. For B, they want BH. So this time, we're looking at this diagonal. Now, if we were to look at that one on our 3D shape, okay, here's our 3D shape. Well, I don't even know how I did that. We're looking for this length here of this one. So this time, is it going to be easiest if we have a look at this, or I think it's going to be easiest if we turn it kind of side on so that we just look at that triangle dead on, yeah? So we're going to draw that. So we're going to draw the triangle. We've got the point H at the top, E below it, and B pointing off this way. So this is our new triangle. And this is the length we're trying to find, BH. Now, do we know the length of HE, this one? Well, on this diagram, it's this one, and they're the same as this one, isn't it? So we know it's going to be 8. We know the bottom length BE because we just found it, it's 15. So now we have to find BH. Again, it's the hypotenuse, so BH squared equals, I'm going to cut a few steps out, square root of 8 squared plus 15 squared. So BH squared doesn't equal that, BH equals that. So BH equals root 8 squared plus 15 squared. So 8 squared plus 15 squared is 289, so root that answer. 17. And then for C, the angle that they want is this angle alpha here. So it's this angle here. So we're going to copy this diagram, and I like to always do a fresh diagram for everyone I do. And we know that this is now 17. This is alpha. You could use sine, cos, or tan. I kind of just want to go back to this. This took me such a long time to figure out. You know what else is cool about GeoGebra? I can put it there. So I'm after, if I can figure this out, this angle between this line and this line, that angle in there. That's the angle we're after. So yeah, that's between BE and BH. So that's alpha. So we could do, I'm going to use tan. Alpha equals 8 on 15. So alpha equals, what's the opposite of tan? Arctan. And that's a calculator job. Let me record myself putting this into the calculator in case that's what you're struggling with. Ooh. So we're doing arctan, so shift tan. It was 8 over 15. Press sideways, close it. And did they want degrees, minutes, seconds? They wanted nearest degree. If they wanted degrees, minutes, seconds, we would press that button. But they want nearest degree, so that's just going to be 28 degrees. And that's question 1.